Hi everyone, I'm John, and this is Enlight Insights Knowledge Unpacked, where we explore the big ideas and collaborations shaping our future. Today we are asking a practical, slightly wild question. Can polluted water be turned into a safe resource for farming? That's exactly what the Planet Network is exploring. A cross-European collaboration between Tartu, Ghent, and Bratislava that mixes plasma chemistry, wastewater tech, and analytical chemistry to tackle stubborn micropollutants and to rethink how we reuse water in agriculture. With me is Dr. Indrek Jõgi from the University of Tartu, who's working on plasma-based approaches that could change how we treat water and close nutrient loops. Let's unpack how this actually works and what it could mean for farms, cities, and public health. Dr. Jõgi, great to have you here. Could you start by telling us about yourself and your background? How did you get into plasma science and water treatment research?
Thank you. So my background is actually quite broad, but still in the field of physics and engineering. And I started doing my PhD studies actually in the materials used in the electronics. So if we have computers or mobile phones now, then we have lots of tiny transistors and memory cells and lots of materials which have to be used, and with making all this tinier, then you have to invent new materials. So my part in that time was studying these materials, and direction continued doing postdoc. Then I used similar materials for similar photoactive materials for solar energy applications. So even though the application is a bit different, the materials were quite the same. But then it's still far from plasma, but then I started also to study some of these materials. They're useful also as catalysts in synergy with plasma. So back then we had need to also clean air. We have lots of pollution coming from cars, from all kinds of chimneys and other processes. And then it had to be cleaned. There's also bad odors, which maybe not harmful or toxic, but still not convenient. So then we started to use plasma in combination of these materials because they are more efficient, hopefully. And that's when I started to work with plasma. And also I have to say I got the first experience in cooperation with industry, because we had also some industrial collaboration and pilot testing of these materials. And then we also started to use plasma for other purposes, for example, surface treatment, which is used in a lot of applications, but also in cancer therapy. And
Whoa,
that's also the
cancer therapy?
yes, exactly.
Whoa.
So it's very broad field of plasma medicine. You can use plasma in many applications, including the cancer therapy. And that's also the place where I started with water treatment, because human is mostly water. So
That's
when
right.
you treat it, then you will have the water involved anyway. And in some cases, and actually specifically what we did in Tartu is to treat the water and then use the water to treat the cancer cells. So that was the part when I started to use plasma with water, and we also have made some tests with water for agriculture, which is also a very big topic. And yeah, there are some other applications as well. So that's the road how I got to this field now.
That's fascinating because normally like plasma science and water treatment research like they seem like very distinct, far away topics, but you somehow like combined both. But like plasma might sound like something from science fiction to many listeners. Can you explain what plasma is and how it can be used to clean water basically?
Plasma is, yeah, it can be very different. We can have this kind of very hot plasma, for example, all the stars and also sun is plasma. And then we have also cold plasmas, which are created by high voltages. And these can be already practically room temperature. And just to give some examples that plasma is not so common in the Earth. Actually, most of the universe is plasma. But we have, for example, lighting. as an environmental occurrence. And then also aurora borealis, for example, is plasma. Then if we are near the high voltage lines, you can see the humming sometimes, which is corona discharge, which is also plasma. And then still in the office is lots of daylight lamps, these long ones are plasma-based. Spark plugs in the cars are plasma. Maybe you can also remember for some time ago we had plasma TVs.
Yes, exactly. I was going to ask you that basically because I always think that the plasma we have in our blood and the plasma in the plasma TVs are different. But are they the same basically?
No, no, that's something which I'm as a physicist, I usually think of the plasma which I'm learning, but of course in the medicine and especially plasma medicine, it gets quite complex when the people do not know what they talk. So that's a very good question. But yeah, in my case, I did not actually say what the plasma is. It's basically an ionized gas, so a gas which conducts electricity. It has to be also, by definition, sufficiently large. So not every ionized gas is plasma, but that's already details. But that's the important part, and that we can create by applying high voltages and then make some part of the air or other gas conducting. And then that means that we have ions and electrons, and that will create lots of other effects as well. For example, heat, for example, light from the lamps, and also lots of reactive chemicals.
Yeah, but like, so the plasma in our blood, what is that?
Uh, I would not like to answer that exactly. It's biological. Yeah,
Okay, so
sorry.
it has like nothing to do with
No,
the
no.
ionized gas. Okay.
They both come from Greek. So
Yeah, that's true. Like everything else, right? In
yes.
in the Western philosophy.
So the name has the same root, but they came totally separately into the use. So yeah.
Yeah, okay, it's good that we made this distinction because like biologists deal with that plasma and physicists deal with the plasma like the ionized gas, right?
Yes.
Okay.
Yes. Right.
So let's talk about the project. What exactly is the Planet Project? And perhaps more importantly for our listeners, what are these organic contaminants of emerging concern that you're trying to remove from water?
hmm So these two questions go hand in hand, of course, because the project is targeted to remove these organic contaminants, and I would like to start then with these organic contaminants of emerging concern, or maybe it's simpler to say emerging contaminants,
Mhm.
because contaminants which are emerging. And well, the merging already says what they are. They are new in the sense that they are not necessarily fully new chemicals, but there is awareness of them and also their effect. So there is large range of already known contaminants in organic, which are controlled by legislations, and they are usually traditional industrial or agricultural chemicals which we know well, and existing water treatment plants can already treat quite well. But then the emerging concern, as the name suggests, the current legislation is expected to broaden and also then include these chemicals. And that's partially because we have more knowledge of their existence and also what they do to environment and sometimes also to humans, and also partly because there are more of them. So that's the emerging part. And to be more specific, for example, pharmaceuticals,
Mhm.
there are lots of them. People eat them and they get to the wastewater. And these include also antibiotics, which are also part of pharmaceuticals, but yeah, and I have to say that both humans and also agriculture, because if you have animal growth, then you want to also use antibiotics, and it's used a lot. And then there are also important group which are called sometimes forever chemicals, as the name say. They are very stable and do not decompose easily. Uh, the name is also generally for that group pollutant perfluoroalkyl substances, but to be simpler, I will say forever chemicals
Yeah,
in the
like
future.
how does like the Planet Project tackle with these problems?
The planted project, also, to broaden this, these chemicals, they are new, but the effect is, the awareness of the effect is growing, and it's also seen that current water treatment plants are not very useful for removal of these. So there are new or alternative methods which can be used to decompose these. In general, they are called advanced oxidation process or chemical processes, and they include, let's say, catalysts or ozonation or combinations with UV, and there are quite a lot of different types, and also plasma treatment is one of these among these processes. And because they're still quite new, they need to find the best ways to use these processes. Usually also it's not, they are not efficient enough separately. So it's also necessary to combine different processes, and therefore we have to include lots of people from different fields.
Oh, okay. So, like when you mention pharmaceuticals and micropollutants in our water supply, that sounds concerning. Like, how big of a problem is this? Should people be worried about what's in their tap water?
Well, that would be good to be aware of, but I would say it's not so urgent problem for people who are drinking tap water, but it's mostly concern due to the ecological impact, for example, on the aquatic organisms. But there are also cases where the exposure to high levels of these chemicals may be also a problem for humans. And the effect depends. So one thing which I would also like to add is that as I already said, there is ever-growing awareness of the problems. We know more of the effects and also can measure better because the measurement technology is also evolved. And then there are these different categories of the chemicals, and they bring different problems. For example, antibiotics in the wastewater, they will result in resistant microbes. So which are not, you can not use ordinary antibiotics. And that's
Yes.
also a problem to humans because even now when you go to hospitals, you have the problem that sometimes there are very antibiotic resistant microbes, and well, you can get sick in there, and there are more and more of these growing up. So to reduce the number of antibiotics in the wastewater, you can help to mitigate or at least control the problem.
Because of the evolution, right? Like because of the
Yes.
evolution, bacteria got more resistant. Yeah. So your project has this interesting dual approach, not just cleaning water, but also using plasma for nitrogen fixation to reuse that water in agriculture. How does that work? Are you essentially creating fertilizer from treated wastewater?
That's yes, the question of not so much creating fertilizer, but putting fertilizer also in there. I was not going too specific to the plasma effect before, but generally, if we have use high voltages to create the plasma, then in the plasma we will in the plasma in air we will decompose nitrogen which is there and oxygen, and then these will react which is each other. And just to say, we had nitrogen fixation. Usually the plants cannot use the nitrogen from there. There are some plants which can, but usually you have to make fertilizers. And so now if we use plasma to combine nitrogen and oxygen, we will get nitrates, for example, and these are now useful for the plants. So if we use plasma, we will anyway, in the air, we will produce them, but we can tune the plasma properties to have more of them. So this water, treated water, we not only get rid of all these contaminants, but also we will include or add fertilizer. So in the agricultural application, that could be more beneficial.
So it's not only a purification process, but also a fertilization process, right?
Yes, that's true. So another part or point of view is that sometimes we do not want to have this contamination. Not sorry. Uh, Sometimes the additional fertilizers are not wanted
Mhm.
when we are not using it directly in the wastewater or in agriculture, but when we are using the water, but just getting to the environment, then sometimes it brings eutrophication or too much growth of plants. So it's also the opposite way that we should know how to not put fertilizers inside.
Yes.
But the scientific part is the same. We want to know how and how to get more or less of these.
But so far, do we know how to omit fertilization process, or are we in the process of learning how to omit some certain fertilization, or like keeping some of the pollutants intact or something?
There's some knowledge is already there. Yes, it depends on the type of plasma source because there are lots of different ways to create plasma, and some are more beneficial for the production of fertilizers, and some are less beneficial. But if you also want to have removal of these contaminants from the water, then of course there is usually some kind of trade-off. So we have to find the optimal solution
Yes,
also for
and
that.
I was thinking of, so like if we clear the water from all these contaminants and pollutants, doesn't that mean that in the evolutionary process, some of the plants would get weaker because they don't have to resist these pollutants or contaminants. So, like, throughout the time, they would become weaker and weaker because they don't have to resist.
That could be an option, but these contaminants usually are artificial, so they were not there, let's say, thousands of years ago.
Okay, okay, okay.
I forgot to say before that there are also ordinary pharmaceuticals
Mhm.
which are there, and also similar, let's say, caffeine, which can be bad for the fish, for example, because they get more energetic and maybe less careful.
Like all of us, yes.
Yes, and then there are also another big group is this kind of, which I said, forever chemicals, which have shown to produce cancer and also immune response reduction. So they're in large amounts they're dangerous. And but all these are artificial. They
Yes,
were
yes,
not
yes.
in the nature before. So in that sense, I don't see the big problem that if we have clean water, clean from these contaminants, that it will somehow make the nature weaker.
Okay, I see. I see. Makes sense. So you mentioned that existing water treatment methods have deficiencies. What's wrong with the current approaches? Like, why can't conventional treatment plants handle these micropollutants?
Uh, because the chemicals tend to be just too hard to remove. They are too strong, and then they tend to be chemically inert and also not easily biodegradable. There are also not much of them, and usually, so to say, they are diluted, so small amounts in there. But the current methods are, would say, more efficient for the removal of large amounts of pollutants. So if you use just, let's say, water treatment, partly they will remove the solids. So if you have the wastewater, then some solids gets down, the oil is taken off from the surface of the water. Then there may be some biological methods to decompose the organics because they, so to say, eat the organics in there. But these emerging contaminants, they are not well, removable by these methods easily. So there has to be something addition.
Yeah, and that's where you come in, right? With the project.
Yes. Mhm. So in our case, we have more chemically active species. As already said, the plasma produces, decomposes oxygen and also water vapor, and then these radicals or other active species will decompose.
Yes, yes, yes,
Sometimes
yes.
they oxidize, could say that we will burn the species. Sometimes they will break the species apart. So depending on the specific chemical, and they're also not very efficient, or would say they need energy or they consume some chemicals, but they still even now best options, but what we would like to see is to further optimize and find the solutions which are economically viable as well.
Like when we zoom into this like microcosm of different bacterias, how many pollutants, for example, or contaminants are we talking about?
Many different types, or you mean the concentrations of these?
No, no, types. I mean, how many different types? More or less speaking, like average.
I would think thousands,
Thousands, right? Okay. So it
even more
has to
probably.
even more probably. So it's really so difficult to deal with them one by one. So are you using AI or something to help you through your research?
Not yet. Usually we have to find some specific contaminants which will represent a certain group, and then we can remove these, also compare different methods for the removal, because it's important to know what method is best for specific type. And then we can make some, say, extrapolations or think also about other types of chemicals. But that's only one part, because, yeah, as you said, it's one big problem that there are so many of them, and each have different effects. So it's not possible to remove all of them. We haven't included AI, but it's something for the future anyway, that we have to find something which works with the big data. But there's
Yes.
also other part, because we also have mixtures of these chemicals, and we do not know what works for these mixtures the best, and how there will be sometimes synergies. So if you have a mixture of these contaminants, they may work even worse or to have more problems. But then we can also determine the toxicity of the water. So not specific species, but generally the toxicity of the water or genotoxicity of the water. So we may not know exactly what specimen does what, but we know the effects of the treatment in general.
Okay, okay, okay. I see. Uh, yeah, because we observe the toxicity of the water, right? And then we conclude that there must be some pollutants that we are not aware of. And then you dig deeper.
Or if we have thousands of different pollutants, the removal or treatment method affects all of them somehow, but we may not know the specifics of that, but we know the general effect.
I see. Okay, now it's getting more clear. Like sometimes you eradicate thousands of pollutants, but you don't know which one was the cause, right? I see.
Yes. Mhm.
But you nevertheless like eradicate them. I see, I see. And this is like a big fascinating project. Your network brings together like three universities, Tartu, Ghent, and Bratislava, each with different expertise in plasma chemistry, analytical chemistry, and wastewater treatment. How do these different specialties complement each other?
So it's actually good follow-up question for the previous part, because we have different aspects to view. And yeah, in general, I would say that the science is nowadays very focused and narrow in certain fields, because there is already huge amount of knowledge. And if you want to learn something new, you have to know even in this small specific area already a lot. So one person or one group of persons is not able to know everything about usually for the applications which need to have different points of views. And for example, now in relation to plasma, we have different technologies, and in each university we have one group who works with plasma. So we have complementary knowledge of different species, and also maybe the measurement methods or analysis methods for the plasma. So even in that sense, it's good. And also we can have like work with other groups dealing with other aspects, that we always have someone who knows the plasma. Then there is, I said, the best effect from the combination of plasma and other treatment methods, probably not single ones. And then there is need to know the technologies also of the water treatment. And this is covered by, for example, Department of Inorganic Chemistry in Comenius University in Bratislava, and Liveto Laboratory for Industrial Water and Ecotechnology in University of Kent. And they deal with different advanced oxidation processes, for example, catalysis, but also they know more about the water treatment processes in general. So they bring the additional expertise in the broader sense for the oxidation processes and water treatment. And also in Tartu, we have chair of colloidal and environmental chemistry who studies the biological methods for the removal. And they also have been in contact and in contact with water treatment. So they bring also this value. And then we want to know both specific chemicals, what happens with them when we treat the water, and the toxicity effect. So we have the group of analytical chemistry who has good analytical technologies or methods to actually measure what happens with these species. I have to also say that if we have specific contaminant, if we remove that, we can see maybe with some methods that there is less of this contaminant. But that doesn't mean that we have removed the toxic effect. We have maybe decomposed it to something which is still toxic. And there can be tens or even more intermediate species in this decomposition. So it's good to know all of these, or at least most of these, so we know that what we have actually achieved, or if we have done anything good at all. And then the other part is the general toxicity, as I already explained, which gives us the overall picture. And that's also very good that we have the general toxicity group in Bratislava. So I think we have quite broad knowledge. And yeah, I have to say that we had just recently a training school at the end of May. And then that was the first one. And it was really nice to see all these complementary knowledge coming together. And I also learned a lot from there.
Yeah, that sounds like a fascinating, huge collaborative project that is bringing together very wide variety of fields. Whoa. And let's talk about the economic side of things. You're working with actual wastewater treatment plants and technology companies, right? When you approach them with plasma-based solutions, what's their reaction? Are they ready for this kind of innovation?
Uh, yes, when they need, I would say. I would say that the companies, as you can expect, they are very pragmatic. So if they already have the working solution or the process is working, then they want to continue as it is, because otherwise they have to do investments and so on. But then if we have now these emerging contaminants, and let's say in Europe, the European legislation is also starting to regulate the amount what we have in the water, then of course the companies also need to adapt. And then they will look for the solutions which could help. But of course, they need to know not only the specifics, or say also all the scientific knowledge is not so important for them, but they want to know, they want to reach the goal that we reduce this amount of contaminants, and they would like to have that as cheaply as possible, of course.
Yes.
And not only as a scientist, but if I also want to have tap water, that's also my interest to have it as cheaply as possible, of course. So it's not only companies or industry.
That's also true, but like, can we say that our project provides a cleaner solution or like a better solution than some of these companies out there? Because like I mean, you are regulated by European Union, right?
Mhm. Uh, so currently it's still evolving, which I did also not say that part which helps also the companies to innovate is when there is some inclusion of national or European projects, which usually go hand in hand, that there is some kind of change in the regulations, then there is also often possibility to apply for the project. So it's less risk for the companies for something new. But then concerning the sorry, I forgot the question.
Yeah, the question was like, are we providing a better solution to this problem than some of these like technology companies out there?
It depends. There are some technology companies out there, especially in case of generally advanced oxidation processes, which can be applied, but for some emerging contaminants, there are actually no good or cheap solutions yet available. And for example, these forever chemicals are one example where the other methods are not sufficiently efficient, and plasma can provide more efficient removal. But in that sense, there are also not many industrial applications yet, because one issue with plasma is that it's not so easily scalable for the water treatment. My background, I was also working with air treatment. In that case, we have large amounts of exhaust air which can be treated, and the plasma is actually used in industry. But in case of water, it's a bit more complex, because we have to get the plasma chemicals into the water, and that brings additional issues. But that's still a problem, that we can show that in small scale, small amounts, the plasma is more energy effective and can remove the species. But how to scale up this to the large water treatment plants, because it's really large scale in there, and that's a problem. There are some pilot devices which I'm aware of. For example, in United States, also there was some time ago a study in hospital wastewater in Finland, where I know that also one scientist from Estonia, not in University of Tartu, but from Tallinn University of Technology, was involved in there. And in Belgium, one of the partners knows that there is also already scaled up device which should be running next year or something. So it's still not yet there, but it's one of the effects which we want to have with the project, that we can actually scale up and help with that.
Yeah, and that's why we have the project, right? So you're actively exploring that as well. And let's talk about the practical side. If a city wanted to implement plasma-based water treatment, what would that look like? Are we talking about completely new infrastructure or additions to existing plants?
The second one is generally what we foresee, that because the plasma and the other, let's say, advanced oxidation processes, they usually are not very efficient for large concentration or large amount of organics removal. So that's more efficient to do with the existing technologies. So what we foresee is that we have these new technologies as one step in the bigger plant. So still the solid waste and most of the organics, which can be used for the existing methods, should be removed by these methods. But the plasma or also complementary advanced oxidation methods, they could be used in addition to remove these particular contaminants. I think there's also the problem that for some contaminants, they can also suppress the biological removal because they're harmful, the biological agents. And then, so in that case, there may be also that we need to have some process before this biological removal. And that's also one part which we want to study in the project, is what is the best way to apply this technology. Is it before or after certain technologies? There is also not too much knowledge on this as well. So that's also one thing which we want to study.
Yes, and I know that like you're currently exploring these problems of implementation and this water treatment, but are there other countries or regions that are already implementing some of these plasma-based water treatment successfully?
Well, I would say that not really. For the large-scale waste treatment of plasma-based, the same scaling issue is with everyone. Then for advanced oxidation processes in general, they are more usage. But then it's also one thing that we do not know always. If company does something or there's some industrial process or device to use in treatment, how it works exactly. So that's not fully visible. But at least to my knowledge, they are not so. Yeah, these methods are not yet used, and there are still active research going on.
Yes, yes, and this is a huge and varied field that has like this overarching spectrum, and you're training a new generation of experts with what you call a broader knowledge base and versatile skill set, right? So, what specific skills do these future water treatment specialists need that current experts might not have?
Well, to use all these methods together, you need the knowledge of very broad range, usually not given in one specific field. So we have the general water treatment plant, which the experts need to know anyway, but also more about the specific compounds which we have, the toxicity of these compounds, the measurement methods, how to actually measure these, and also the removal methods, different treatment methods, chemistry, plasma biology, and so on. So there is some additional aspects, as already said in the question itself. But there is also a part that it's not only the water treatment experts, but because it's still emerging, and as the emerging compounds says, we will have probably even more chemicals coming in the future, which we are not aware. So in general, we also need researchers or people in university who know more about this field. So that's also including the experts, not only, let's say, water treatment plants, but also universities themselves, that we need to have a broader expertise to actually get a solution for this problem.
Yeah, it's like a constantly evolving field, so you would always need new researchers who are actively exploring the field itself. And looking at the bigger picture, how does Planted fit into the circular economy? You're not just cleaning water, but creating value from waste, right?
Yes, exactly. That of course, even the clean water itself is value.
That's
That
true.
if you have contaminated water, then you often cannot use it in, let's say, agriculture or some other applications. So taking off the chemicals in the, I think one of the ordinary thing could be to, if the chemicals remain there, that you will just leave it to the groundwater or somewhere, and it somehow also gets cleaned eventually, or at least there's less of these chemicals when you use it in the tap water. But when you can directly use this water in some application without letting it to the environment, then that's better. And then, as already discussed, we can have additional fertilizers in there, so that will, in agricultural use, it will be even more beneficial.
So yeah, agriculture would have a big benefit from it, right?
Yes. Yeah. What we have done also before, and what is quite big topic, is the plasma use in agriculture. So just specifically treating, let's say, seeds before the germination, and then it also not only helps to have fertilizers, but it also changes the seeds in a way that they will grow faster. But if we can use the wastewater for that, that would be even more beneficial. So we don't have to use scarce water sources for that.
Yes. And picture 5 years from now. What would it mean for Planted to have truly succeeded? How would you want our entire approach to wastewater to be transformed by then?
5 years is, of course, quite fast going. And I would say that partly we have to look at the short-term project here. So half of that, we have the project itself. We would like to grow up the community, teach new persons, but also learn by ourselves. We would like to, during the course of the project, we have to combine these methods and see how they work. Then we would like to broaden the scope, and also involve more people, involve other projects to actually get to the large scale would be one important step. And I think in 5 years it is possible, but yeah, it needs also some input from the industry. And these are always not so easy to predict how it happens, because you have lots of different concerns also, and yeah, it's already less predictable in that sense. But I would like to see that we really have the plasma treatment and other processes used in the industry, and at least one problem with the current emerging contaminants we have, if not solved, then we have the solution ready.
Yeah, it seems like a very clean and safe approach. Yeah, I'm sure the companies will adopt it nevertheless and eventually. For our listeners, whether they're students, policymakers, or just citizens concerned about water quality, what should they know about the future of water treatment technology?
Well, at first, I have to say that I'm not an expert in the broad field of the water treatment technology, but in general, the trends which I think happening or going on already now. One is this kind of better knowledge or monitoring of the water, so to say, smart systems. We need to have more sensors. That's also connected with the analytical chemistry part, which we have involved in that if we know about the water quality, then we can also adjust the system. The flexibility is also in there, that we should be in the future be able to more flexibly adjust to the changes. So these two go hand in hand. Then the other part could be decentralization, so that we don't have only the big, large treatment plants which mix together different sources, but we could have the smaller plants specifically in certain points. Let's say medical waste could be treated as close as possible to hospitals. Sometimes it's already done. Or maybe agricultural waste near the agriculture and so on. So be specifically in the place where it happens. Then we have, for specific contaminants, we have better or more efficient systems in that case. And it's also helpful, let's say we have less pipelines and everything, so that could be also helpful. And then, of course, always the energy consumption is a concern. So we would like to see smaller energy consumption and possibly also recovery of the species. Because the problem is that we have now also with plasma, we can maybe destroy these things, but a good alternative would always be to get something valuable out, let's say some chemicals, and there are also methods which can do this. So these are the three trends which I would bring out, which hopefully happen in the future.
Yeah, thank you so much for the answer. And like talking about this energy thing, how energy intensive is plasma treatment compared to conventional methods?
It's generally still quite energy intensive because it uses electrical energy to have the chemicals produced. The good part is that we can produce the chemicals where we need it, so there is no need to transport something from one place to other. The other good thing with plasma is that we have its electrical device. We can adjust the energy consumption depending on the waste. So as I said already, the smart systems, we know that there's some change, and then with plasma, we really can have more or less energy, and so also better or say more intense removal or less intense removal. So these are the good part, but it's still energy use. And in some cases, it's not as efficient as some other methods, but for example, with these forever chemicals, there are no other methods as well. So in that sense, it's the question that we have something which works.
That's true. Yeah. Thank you so much, Dr. Indrek Jõgi.
Thank you.
That was a fantastic conversation. Thanks again to Dr. Indrek Jõgi for walking us through the science and the practical challenges behind Planted. If this episode made you rethink water, hit follow and share it with someone who cares about food, cities, or science. Thanks for listening, and until next time, I'm your host, John, and this has been Enlight Insights Knowledge Unpacked.